So far we've only thought about objects without thinking about gravity. So this time let's just have a bit of a think about what gravity does and the work done by gravity when an object moves in one dimension. So we're just talking about up and down. We'll think about 2 dimensions shortly. So when we're doing this type of problem, what we usually have is some kind of datum. In this case, we'll take the ground as the datum. So that would be our 0 point. And then we've got we've got a y direction upwards. And this object starting from some height h. And so if we were to release that ball and it were to let it fall to the earth, work would be getting done by gravity. And so therefore we'd have work done as just force times delta S. Sometimes you just write S if we're just thinking about the distance. Sometimes you might think about change in displacement if we're thinking about multiple different steps along the way where it's changing displacement. Or we could also write it just as displacement minus initial displacement. And I'll use that this time. So then in this case, U is equal to M times G times the displacement minus the initial displacement. So that would be, in our case, we're thinking about the ball dropping from here to here. And so final displacement is 0, initial displacement was h. And also we have to be careful, the force is acting downwards as well, so it's also negative. And so therefore the work done by the force is going to be, those negatives will cancel out, it's going to be equal to mgh. So if this ball was going downwards, then the work done by that force as it goes down would be equal to mgh. Now, what would happen if, so assuming air resistance is negligible, what that work is doing is it's converting energy. So it's a transformation of energy. You can't really create energy unless you're a sun. And so therefore you're always thinking you are always transforming energy. And so as we go down, it's obviously without air resistance, it's getting transformed into kinetic energy. So this thing's speeding up as it goes down. So it's getting transformed into kinetic energy. The question is, what's it getting transformed from? Well, usually we say that this energy that this mass has due to its height above a certain position is called its gravitational potential energy. So that's gravitational potential energy. And we just define that as the work that gravity could do if the position of that object changes, or the work that it would do really, if that object goes from its position to the datum. It's the work that gravity would do. Now, it does not need to be positive, it could be negative, this gravitational potential energy. And so you might not choose your datum on the ground, you might choose your datum to be that position. And that might be our datum 0 there, this might be negative, and then in order for this ball to go from that position to this position, you'd need to do work against gravity, and so that would have negative gravitational potential energy if you start here and you're going back up to here. So at this position, it's got negative gravitational potential energy. So, I don't know if there's too much more I want to say about that. So what we could do actually is we could give a more general form, which is mgy, and that could be positive or negative depending on where you choose for your datum. Now there's one more way of thinking about this actually before we go on. So we can think of the, let me just change it back. Usually the 0 will be at ground level, or you just choose your datum to be the lowest point that this thing's ever going to go to. So usually you'll have usually it will be positive. But there is another way of thinking about that. So here the potential energy, by definition, we're saying the gravitational potential energy is the work that gravity could do if this object is taken from its starting position to the datum. There's another way of thinking about it, is that the gravitational energy is the work you would have to do. So let's just find another initial position. So let's take, I'll just put that back in again. So let's say this here is h. And if we wanted to move this from the datum to that position, what we'd have to do is hook it up to a crane or something. and we'd have to apply a force that was equal and opposite to gravity. So this would also be mg to lift this thing up. And so therefore, the work that we would have to do to lift this ball from this position to the datum is going to be that force times the distance, which is also going to be, that would end up being positive in this case. That's correct. And so we'd end up again with mgh, because we're going to be got this force mg, we're lifting it in this direction, positive, so it's the energy, the work that we would have to do to lift that ball from the datum to that height h would also be mgh. Okay, so that's gravitational potential energy. And in each case, for these situations, you're getting gravitational potential energy getting converted into kinetic energy if it was going down this way. It could also be the case that you've got a projectile or something that's being shot up, and then, let me just move that, yep. So it's getting shot up. So then it would be a case of the kinetic energy would be getting transformed into gravitational potential energy. It'd be slowing down, slowing down, slowing down, and then it would stop. It's all being converted to gravitational potential energy. And then if there was nothing catching it, it would start accelerating down the way, and all that potential energy would be converted back into kinetic energy. And all of this is assuming air resistance is negligible. Otherwise, some of that energy is going to be lost to air resistance, and we'll quickly talk about friction next.